Okay, so in this lesson we are going to revise the geometry test, and can I just say that your test this year, expect much the same as what we sort of are going to go through today. We will go through some circular theorems and stuff towards the end of next week, but because we're going to lose our double, I think it's really important that we get through a lot of this stuff. First of all, the number of different angles in the following diagram is, well, what did we look at? Didn't we have this Z rule? Do you guys remember that? This Z rule? Isn't G and B the same? Yeah. Okay, so G and B are the same. Okay, and what are they called? What are those two angles called? Are they complementary or? And yeah. Okay. What about if I was to say then? What about E? Is E the same as anything? Is E's the same as angle C? And C's the same as F? And the same as D? And then H is the same as B? That's right. There's only the answer, the number of different angles. The number of different angles is 2. Very well done. Okay, if the sum of the interior angles of a polygon is 530, then the polygon has the same so many sides. Now, let's have a look. Isn't this the sum of the internal angles? Wasn't there a rule for that? Wasn't it n minus 2 times 180? Now, if we've got the sum of the angles is 540, then that is equal to n minus 2 times 180. 180 goes into 540 conveniently 3 times. So I'm going to say that 3 is equal to n minus 2. So how many sides do we have? 5. So the answer is none of the above, yes? Yep. Good. Now, when we're talking about congruence and proving, which congruence test proves that the triangles ABC and BAD are congruent? Which one? Now, remember, we've got, can we say that side, side, side? No. Why is that? We don't have a third side. Okay, good. All right. Now, what about, we've got angle, this angle here is the same as this angle here. Okay, so, but that's not really going to help us. This angle here is the angle here. But could you say that maybe, are these sides the same? All right, so what are we looking at here then? What's the answer? I'm going to get you to think about it. I'm going to pause it for a second. I'm just going to get you to pause. All right, so I'm just going to resume this. And look, AD and BC are the same side. But they also include the two angles. So it's angle, angle, side. And that's why they are what we call congruent. Okay? Now, we looked at similarity yesterday. Which similarity test proves that the triangles EDC and ABC are similar? Well, first of all, can you see here that we're talking about ABC? So we're looking at this triangle here. Looking at this triangle here. And then, of course, we're looking at the EDC. We're looking at this triangle here, the bigger one as well. Now, what can you tell me if obviously they share a same angle here, don't they? Would you agree with that? Okay. Now, if these lines are parallel, would they not share this angle as well? Would you agree with that? And if these two lines here are parallel, if these two lines here are parallel, then wouldn't they share the same thing here? So what can you tell me about now certainly their sides are not the same. So what is it? It's 3 angles, isn't it? Okay. What? Well, I'm going to pause it and we'll have a little bit of a go. All right. So you made a couple of you made a very good point. when we're proving congruence, you cannot use angle, angle, angle at all. But when it comes to similarity, if you have a triangle, two triangles with the same angles, then they are similar. Same thing, if the ratio of sides is the same, then it's also similar. And we can also do the same thing with two right angle triangles, because they are both right angles. If the two sides have some enlargement factor, then you can also say they're similar. So yes, if we were talking about congruence, definitely this would be ruled out. However, because all angles are the same, these two triangles are similar. Okay? Very good. I think Callum's pretty excited over there. What about when a straight line cuts through a set of parallel lines? When a straight line cuts through a set of parallel lines. Let's just draw it. Okay, let's say that these lines are parallel. A number of pairs of angles are formed. These pairs are called what? What are these pairs of angles called? If I had A and I had B here.
Alternative, co-interior, corresponding.
Thank you. Alternate, co-interior and corresponding is the answer. Well, because we have alternate at angles, we're talking about this little Z thing. Remember the Z thing? Okay, so if I had angle C, is angle C and angle D. What can you tell me about angle C and angle D? They're the same, aren't they? So, yeah, a little bit of, it's a tricky one, especially if your English isn't so up to speed, but we're creating alternate, co-interior and corresponding angles. Okay, now which one of those angles are alternate?
A and B.
A and B are alternate. What about co-interior?
B and D.
B and D are co-interior. And what about corresponding?
C.
C and D. Beautiful. Well done. Very good. Now, given that AB equals CD, what does that mean? It means that obviously that these lines here are the same length. AB and CD. What do you notice then though? Now, we really haven't, we're talking about this being the centre of the circle. What can you tell me about these two lengths here?
Oh, they're going to be the same.
These two lengths are the same. Would you agree? Which means, would you agree that these angles are the same? Yes? Now it says AB and angle AOB is 48 degrees. Then angle OCD. Now, it's the same thing. These angles are going to be the same too. And what's this angle going to be in here? 48 degrees. Now, how many degrees in a triangle? 180 degrees minus 48. Just one sec.
132
Is equal to 132 degrees. Now, given that these two angles here are going to be the same, and they're also going to be the same here, then whether it be angle OCD or OAB, OAB is going to be half of 132, which is 66 degrees. Sorry, did someone have a question? Just one sec, just one sec. Shh. All right. What was your question? Shh. What was your question? Because if you have the question, go on.
I just didn't know why you had to divide by 2.
Oh, okay. Because of course we're looking at a triangle with 180 degrees in total angle, and we've got one of the angles which is 48. But we know that 132 degrees is the sum of these two angles here. Yes? That one there and that one there. And because we know that they're the same angle, that's why we're dividing by 2. All right. How are we feeling so far? Good. Now, by the way, in your test, your multiple choice questions will be worth 2 marks, because a lot of the time there's going to be more than a minute or 2 worth of work. So that's why it's going to be the same. So you've got to get good at multiple choice questions. All right, I'm going to pause the video, and I would like you to have a go at questions 7, 8, 9, and 10, and we're going to review those in about 5 to 10 minutes. I'm going to give you 5 minutes, okay? I'll stop the video now. Well, actually, I'll pause. We're back in the room. All right, now, the angles ABD and DAC are respectively? Well, ABD, first of all, we have to know what we're talking about here. We're talking about the angle in here. And DAC, we're talking about the angle in here. Now, this could involve circular theorems. The one thing I'm going to say to you is this. One of your circular theorems is that if I have a line going through the origin, okay, if I have a line going through the origin, which I do, then this line here, then if I draw two lines to the outside of the circle, it's going to make an angle of what do you think? What angle does it look like?
Right.
It's a right angle. And that is actually one of your circular theorems. And we're going to go to that. So, circular theorem. So, that's one of our circular theorems that we're going to cover. So, if that's a right angle, and it says here that, what about, what angle then, if I've got this then going through there, then what's this angle in here? What's this angle in here, ladies and gentlemen? It's also a right angle. Now, if that's a right angle, and I'm going to get my eraser out just so we can see it. If that's a right angle, and that angle in there is 37 degrees, and that angle in there is 18 degrees, how can we work out, well, hang on a minute. If this thing here is a triangle, and we know from one of our circular theorems that this is a right angle, that's 37, that's 18, okay? So what have we got? We've got 90 plus 18 plus 37 plus this angle in here is equal to, we're going to call that angle X, is equal to 180, isn't it? Okay, so now we've got 37 plus 18 is 55, 90 plus 55 is 145, 35 degrees is this angle in there. Now, what is that angle? That is ABD. So, angle ABD, we've just worked out to be 35 degrees. So, ABD and DAC, which is the only one which
E.
the answer has to be E. Does that make sense? All right, so we've actually covered one of the circular theorems today. Now I'm going to pause this video just for a second. I'm going to show you. Good. All right, there are a number of circular theorems, and to be honest, a lot of the time we actually cover these theorems in Year 11 specialists as maths as well, and some of the students find them pretty tough. It's not an easy topic. But let's have a look. Circular theorem number 1 states the angle at the centre is twice the angle at the circumference. Can you see there that angle alpha is twice that out of angle beta? That's one of your circular theorems. All right. Now we're going to go through this in more detail. That's right. Didn't I just go through that one with you guys? If I've got the angle in a semicircle, in other words, cut through the middle, if I have my this thing here, if I have if I draw a line between 2 points, the two ends of a semicircle, what's the angle? 90 degrees. Okay. And exactly, that's right. The angle is also double. Fantastic. What about angle 3? Now see where it says BE, that's what we call a chord. Okay, now angle if I draw from one end of the chord, see here, one end of the chord to here, and one end of the chord to here, what do you notice about those angles? They are the same. Okay?
This one, that's why it's 37.
Yes, exactly. Right, very good. And that's why I will go through this in full. I'm going to only... What about this one? It says opposite angles in a cyclic quadrilateral. What does a quadrilateral mean? 4 sides. Add up to 180 degrees. You can see there that if I draw how many chords have we got? 1, 2, 3, 4. A chord is when we draw a line from one end of the circle, or sorry, from the outside of the perimeter of the circle to another point on the perimeter of the circle. So this is what we call a quadrilateral, and that is another circular theorem. Okay? That's exactly. That's right. Beautiful. Now, circle 5. Then we start getting a little bit harder. The 2 tangents from a circle are equal. Okay, so if I draw this line, can you tell me that? Can you see here that the line EC is the same distance as from DC? Okay, so we're going to go through these in more detail, but I just wanted to show you the angle between a tangent and the radius of a circle is 90 degrees. A tangent is always 90 degrees, is it not? Okay, has anyone seen the tangent? If you do a tangent to anything, the tangent is always at 90 degrees. All right, for example, when we looked at linear equations and we looked at perpendicular, they were actually what we call tangents. And we get on and forth, then we talk about alternate segment theorems. We're going to get to those later. And then finally the perpendicular bisector. Now, there's 8 theorems, but to be honest, the main ones that we're going to cover are this one, this one, and of course this one, and probably not so much that one, or that one. All right? So, now, getting back to my thing. So of course, in this video, or in this question, we needed to use law 2, which was of course, the semicircle perpendicular. When we drew 2 lines from the semicircle, that angle was perpendicular. Now, just quickly, the value of A within this regular pentagon. How many sides to this pentagon? 5 sides. So don't we have 5 sides minus 2 times 180, which is what? 540. And how many angles do we have? Divided by 10? 54. Excellent. That's a really nice picture there, Jamil. All right, let's go. As I can, hopefully. Now, first of all, let's look at these triangles. The first thing I do is we can't just say these triangles are similar, and you can't just look at this and go, oh, that's a right angle, because it's not. Okay? Just because it looks like a right angle doesn't mean. The only time you can assume it's a right angle is when they actually tell you it's a right angle. So, in this question, what we're going to do is I've got 44 degrees here, so that means that angle C has to equal 180 minus 44, which is what? 136 degrees. Okay, I've got 136 degrees there. Now, if I've got 136 degrees there, then what's this angle in here? That angle in there is 44 degrees. Very good. Now, if that angle in there is 44 degrees, and I've got 44 plus 50 is 94, then that means that this angle in here has to be 86 degrees. Now, the thing is that how do we know that these triangles are similar? Is there any way in which we can work out angles Y and angles X? Is there any way? How do we know that they're similar? Is there any rule we can use? What's that? No? Well, what about the Z rule? Can we do the Z rule somewhere? Can't we do this?
Oh, yeah.
Shh.
50.
Can't we do this? Can we do this?
Yeah. Or you can do it the other way.
All right, good. So what's, given that 86 is over here, what is x? What is x? I've got 86 over here. So x is 86. And then if 86 plus 44 adds to what? 130. Then that means that y is equal to 50 degrees. Now, all angles are the same. So therefore we can say that ABC is similar to CED, if that makes sense. Now we've got it says here find x. Well, we've just found x, haven't we? X is equal to 86 degrees, and of course we've done our working out already. Makes sense? All right. Now what about over here? What about over here? I've got a four-sided polygon. So first of all, how many degrees are going to be in my four-sided polygon? 4 minus 2 times 180 is equal to 360 degrees. Now, this is where it gets tricky. My 360 degrees is equal to, I've got my 90 here, so that's fine. I've got 90. Then I've got plus 120. Then I've got plus 2x plus 55 degrees. And then I've got plus whatever this thing is. Okay, and we're going to just call this y. But you know what? Let's think about this mathematically. I'm not going to call this, I'm just going to say that x plus 100 plus something is equal to 180 degrees. So what is it? 80 minus x. Don't go anywhere yet. 80 minus x is that something. So this is going to be 80 minus x. So I'm going to say plus 80 minus x. Now, of course, we then go ahead and do some collecting like terms. Don't go anywhere until I finish this question. So we've got 360 is equal to 210, 290, 345 plus x. So what's x? What's that? X is equal to 15 degrees. Okay, now we're going to continue and have a part 2 to this, but we're going to look at some circular theorems in our class next time.